Hello everybody, welcome to another stream. How are we doing? So last stream was wrapping up on the parser for this encoder file since the design has been fully fleshed out. So what I've gone and done is actually finished it off off stream to the point where all the code is written out for the parser now, and it obeys all the rules. It parses all the stuff that's inside the design documentation that we did. But we've still got to get it to semantically work and obey all the rules. So I've made this file here, which we can use for testing this encoder and decoder system. So I think we'll make it be, let's just do file target, text and binary maybe, and then we'll say it's got a magic number of 1, 2, 3, 4, 6, 7, 8, 9, I guess. Wait, what's the magic number again? It's 8, yes, 8 of them, isn't it? Yeah, like that. Yeah, so what we need to do is I still need to test the parser, make sure it works, but I'll do that later. What we want to work on now is just making sure the logic that's defined out in this encoder system design document, that all the rules that are listed out here actually are implemented in code. So that's what we're working on today. Hey, the Ibra dev, welcome. Hello, how are you doing? Oh, there we go. So yeah, I think one of the main things we need to do is, so we have two files, right? We have the, when you make an encoder file, which describes the data layout of the stuff you're encoding and decoding, there's a database file which gets created on the first time you run the generator. So this is going to maintain the history of all the types and everything like that. So we basically parse the database file, then we parse the encode file, and then we merge the encode file into the database. So we'll probably start working on that merge function and just make sure those rules make sense. Or maybe we should at least get a new one generating. Yeah, let's get a new one generating at least. So I don't think it needs to do a merge. Ooh. Yeah, let's try and just get a database file working. So let's delete that database one. And we'll start from scratch. And let's see what happens. Cool. So we're on the scripts. Right, see how this goes. All right, so stuff isn't, compiling fully. So let's just correct that. All right. So I've added a new function which is called skip whitespace new lines and comments. So we support comments. I think it's part of the problem. Oh, there's more of them, is there? Oh, the CSON reader, interesting. Yeah, this one needs so new lines, comments. Right. Hopefully that does it all. There's a lot of them there. Right, I wonder... Okay. Cool. So now we just need to initialize some global array. All that's left to do, hopefully. Well, okay, sorry, it's compiling now. Now we've just got to deal with runtime errors. So we should be able to output a database file now, hopefully, very soon. So let's go back into the code generator. I've made a new data structure. So gen is the data structure which just houses everything. Well, a new data structure called gen file, and this just keeps track of either the encoder file, which is the one the user edits, or the database one, which is the one which preserves all the history of all the encoded types. And then inside here, you got this gen file. It's got these sort of like, I think we did this last stream actually, some of this stuff. All these target feature flags. What targets are we targeting? Files, GPU, CPU, for networking. And what formats do you want to encode to? Binary or text. And then like every file can have an array of versions, and inside the version it has a type table per version. So the database has multiple versions in it, whereas the encode file only has the latest version, right? And the latest version gets merged into the database one. So we're able to merge into their type table. But yeah, so effectively an array is not initialized. So this versions array is not being instantiated. So if we go into well, I don't know, it's probably main, isn't it? Right, parse file probably should be initializing some of this stuff. Core stack init file versions. So we'll just use the standard allocator we got that's defined at the top of the file, which is just malloc basically. And let's just do 1024 versions. You know, or I could do 64K versions. Ought to be good enough. Yes, let's run that and see how that goes. Oh, we have. Right, that clearly reads a bit wrong. So when we initialize the type table, we right, this is interesting. We have either initialized more or less intrinsic types than intrinsic type enum has. Whoopsie. So this kind of sucks, doesn't it? So why don't we just say we've initialized this many intrinsic types, but intrinsic enum has this many. Table types count, intrinsic type count. Let's try and give that one a go, see what happens. Right, so 45, 44. One too many, apparently. What's going on? So we've got, it's probably because we had a boolean, wasn't it? No. Right, bool. So there's all the basic ones. And all of the vectors. Got a quaternion. Then we've got a matrix and then a transform 3D. So we take a look at the intrinsic type one. It's got all the basics there. Yeah, that works out, doesn't it? Then all the vector 1, vector 2s, they're just missing Boolean. Vector 3s, vector 4s, matrix quaternion. It's done in a bit of a wrong order, to be honest. The way we initialized it. But still, it doesn't tell us why we're off by 1. It's a little strange. But yeah, so the quaternion should have gone. So it's the matrix first, and then quaternion, I think. It's doing a push, isn't it? Yeah, that would have gone the wrong way around. Where's the push for the type? Oh yeah, it would have gone on this type init thing. Right. Okay, so something really weird is going on. We could probably step through in the debugger and see what's going on. Yeah, I guess let's do that. Put a lovely breakpoint in there, and then we'll hop into GF and take a look. So after these, right, so we go to table types count 0, as you would expect. So if we continue up until here, that reads 11. So what is basic type count? Casted to an int. 11, right? That makes sense. So it must be something to do with this loop. We're pushing on one type per. Alright, so how many will now? Alright, 21. So we did 10 more. Right. That makes sense, doesn't it? So we'll do another 2 more 10s. That'll get you to 41. And then how many did we have to get to? It was like 44, wasn't it? Yeah, why? Why do we have 45 in the end? Because it only has 3 more after that, doesn't it? Right, so we come after doing all these vector types. Let's get to here. Right, so look at the number, it's 41. And then you got 3 more types. Ah, crap, what's this? Ooh. Right, it's got an array type. That's not good. There's our bug. So we actually add another type in there. Right. Okay. That's not good. Right, so maybe we'll, because this function does a push, doesn't it, on the number of types. Okay, so what we'll do is we'll manually push them on. So we're like matrix type, quaternion type, and then what was the other one? Transform 3D type. So we'll like just, yeah, do it this way. Pre-push them on in the right order, and then simply just... Alright, so my main concern has got this thing here. Maybe we should remove the assert. Oh no, we'll move the assert upwards. This one is the quaternion. And then this one here is the transform 3D type. Cool, so if we move this assert out of the way of actually instantiating these guys. There we go. Now that assert will trigger if there's actually a problem. Right, so let's give that a run. Let's remove the breakpoint. So hopefully it runs this time. Shoot, what was that? Don't do that. Cool. So we've got a little bit of a parser error here. Expected to begin defining a structure. So at line 4, 6, column 6. Why does it think it's a structure? Or something weird is clearly happening. Did we save out any? No, we didn't save out any database file. Yeah, so, right, clearly my changes have broken the parser severely, so let's take a look at that. It says in parse file. This is a parse file here. We parse the target directive and the magic directive if there is one, or if there requires to be one. The dev directive at the top of the file, if there is one. Then we just loop over the rest of the characters and find stuff. This if there's a hash version. This is only in the database. Now, this is where we go if it's a structure or a union. So I guess I'll put the breakpoint here. Right, so Vance is going to do all the new line sort of stuff, right? I wonder what I did to break this. Right, let's put a breakpoint in there and see what happens. So, next. Oh. Whoopsie. There was no problem. Right, turns out I copy pasted some code and I didn't edit one side of the else. So this side is checking if there's this sort of hash here for this hash version basically. But yeah, there is no hash for hash version. So it goes to the else, and the else was some old code. Well, it's from some copied section. There's not needed for this one. So if you don't parse version, there's an unrecognized directive. Perfect. Rightio, so let's give that a go now. So a breakpoint, okay, the breakpoint's gone. Alright, so expected enum, strut, or table. See, that table thing should have been deleted by now. I did remove that as well. Hang on a minute. Union is the new thing. It's basically just C now, which is pretty cool. So a couple extra bells and whistles. Okay. So table here means type table, but I've just shorthanded it. But it used to mean a structure which had 0 alignment, and it was bit packed, which turned out to be a bad idea. So I've reverted that. We're not doing that anymore. So line 4, column 13. That went a bit too far. Right, so I think we need to put that breakpoint back where we was in that parse file. We should really look for the word version. Right. So I think let's put one of those lovely breakpoints in there. So it's a little bit bizarre what's going on. Right, yeah, keyword is equal to ent type. Oh, that would have passed past the enum bit, right? And then error. Alright, that's not good. So it might have been my skip white space on new lines and comments, which is a new thing added. Which seems pretty problematic. Yeah, I think is a problem. So if we take a look at reader.text, is that what it is? Plus reader.cursor. Oh. Not even that has the word enum in there. That's quite bad, isn't it? So it turns out it's further up. So I guess we'll just follow it a little bit higher. We definitely parse magic. Oh, it does a read until here, doesn't it? And that probably messes it up. Interesting. Oh. Yeah, I see what's going on. Right, these are not good. So at the top of the file now, we have a you say like what is the target for this encoder file? So we're going to target saving that to files, or do we want this to be used in GPUs, or do we want it to be used CPU side packing type of stuff? So you can put them all in here, and it'll sort of like turn on and disable some other features. So we parse that up first, and then we parse this one. But yeah, just because I'm using a text reader and not properly tokenizing it, I've got to get the logic exactly right in the right places. It's a little bit more fiddly. But yeah, so I need to just parse the text properly, because right now we sort of pick. So there could be an optional one which is #dev, and you put it into dev mode. You say I want to upgrade. So this will bump the version, and you can start editing the file a bit more freely. This is optional. So what's happening is that it's parsing. It picks up a bunch of characters, and then it checks to see if it is the word dev. It's not, and then carries on. Meanwhile, it would have taken up this, basically skips this enum word. So yeah, I just need to correct some of that stuff. Hey, Pratik, how's it going? Do you use any lights with your cam for streaming? Yeah, I got these lights here. So I got a couple of them. I recently got them when I changed my setup a bit, because yeah, the green screen wasn't behaving well without the lights. I just used to use the room light at the top, but now I got these two which sit in front. So yeah, they're proper good. Yeah, so this one requires the directive to exist. So doing a read until is fine in this case. The magic also needs to exist only if... Yeah, but it can optionally fail. So really we should make a good just a better way of parsing it. So what we need to say, right, is actually, I might just do something like this. It's a bit bad because it only supports a space character afterwards. But or I could say parse. What could I use? Nowadays, my boy. Compare. So that will parse like the target characters. So this could say like, rather than saying read, we could say like peek until and make another one where it doesn't actually consume the characters. Maybe we'll do that one. Or maybe we can make another one which says peek until, and that will get you a range of stuff. Yeah, that might just be the way to do it. So we'll do that one. Just be a copy and paste to this one. So effectively, you've got a size, and you're saying peek ahead, and you can just keep bumping the size up and up and up. Call it a peak amount maybe. Yeah, and every time you don't find a delimiter, you just up the peak amount by 1. And then at the end, text plus cursor. No, we do go from start pointer with peak amount. I'll do it. Yeah, I think that's what we'll be using now is this peak until, and then we'll tell it to advance afterwards if we succeed. I think that will be the better way of doing it. So we'll do a sort of like peak until, and then afterwards, shoot. So maybe we should parse it into a string, call it directive. How do you read chats when you do streaming? I need another monitor. I can do that with a single screen. Yeah, so people have like different setups. Some people will only stream a part of the screen and they'll have chat sort of like on the edge, which is not streamed because you can stream a sub portion of a screen. I just have my laptop here to the side. It's just an old ThinkPad that I picked up cheap. It's like a couple £100, and I take this with me when I go away places. It's always handy having a laptop. But yeah, so I just put that on the side, and I just have the Twitch dashboard open. Yeah, that's typically what I do. Well, that's what I do now at the moment. I used to have it on my phone, but the phone's a little bit small, and yeah. But some people have multiple monitors. I don't really work well with multiple monitors, really. So I got the laptop here for when I do streaming, at least. So rather than read until, it'll be peek until. And then we can simply... Yep. Then we can say text reader advance by passing the address of reader, directive size. Perfect. So that's what we're going to copy over to those other two places, and that will help us parse those correctly. And hopefully we start parsing the file a bit better. That's all the target stuff. Here's the magic. Yeah, so if we've parsed it, we advance, right? Oh shoot, I did that bit wrong. Hang on a minute. Alright, so after the magic number, there's this dev1 as well. Let's drop that in there quick, delete that line. And then the line is going there. Right, so peek until instead of read until, so it doesn't consume those characters from the reader. Yeah, and then if it was found, then we advance. Right, so that should stop those errors was getting. Let's give that a run. Cool. Nice. So something I did off stream as well, let's give note of this. So yeah, we've got support for unions now. The problem with unions is that if you have a text encoder, you kind of need to know it needs to be a tags union, basically. So right now, I've just made it support tags, so you could say, hey, if it's a union type field, the tag field is this one here. And the great thing about doing it separately is that we could bit pack the crap out of these things using this packing syntax that we've come up with. So these things can all be packed nicely in the structure somewhere. And yeah, we can just reference the field like that. But then the union has to have keys for like each field basically, but it's only for text. Right? If it's binary, you don't need to care about this, but for text we do. Just so we could make the parsing work. If you just only write it out, it would be fine, I think. No, would it? No, maybe for reading and writing, yeah, something like that. So I've had to add this on. You know, in future we could maybe support something that's not tags. Maybe we could do conditions, but tags is what is good enough for now. It's not the end of the world as well. You just need to put a few extra bits somewhere, usually, especially when you're saving that to a text file. So yeah, this is what we've got this key directive here, and it's got a bit of an error. So it's saying unrecognized directive key and type dragon. So if we go to where we find that key, so clearly it's parsed up way too much. So we should have looked for a space, already a tab. Right. Cool, got a bit of a seg fault. Cheeky seg fault. So something is going on here. Well, we tried to do an error, and the context-aware printing, this context thing is probably, this format pointer is probably null. Yeah, so we didn't set the type field. So parse type, and this has range error here. Oh, nice. We did these last stream. These are really cool. So for those packed types, we can put if the minimax value go range or range of the integer, or if the range doesn't fit in the number of packed bits. But yeah, we clearly didn't set the format type, so let's go and correct that quickly. Has range. Yeah, so clearly with these guys, we need to say generator dot format type. So the type is just type, I think. I think so. And that would be the context that we're printing. Right, so packed type min with min 100 and max 300 gives a range of 200, and this does not fit into 8 bits. Yeah, it does. What are you talking about? 8 bits is 256, right? So clearly this logic is wrong. Damn it, that sucks. So most significant bit would be 2. Or it's a bit index. Wait, why is that a less than? Oh, I think I got my logic the wrong way. Greater than or equal to. Yeah, something like that. Greater than or equal to, then it's an error. Boolean logic. Always the wrong way around. Okay, so let's quickly test that and make sure we got that right. So if we go over to the ENC file, so there's another problem that we've encountered clearly. But let's just double check these ones. So it's 256, wasn't it? So we would say 56. That should work, right? Right, so obviously 256. So be 0. Hang on a minute. So we do 3, 5. That works, right? So is the range 256 at that point? Or would the range be 257? Because it's going from 0 to... Well, yeah, it's going from 100 to 356. And that's inclusive. Whereas... Yeah, that's inclusive min-max. Whereas this is like... Yeah, so because it's an inclusive... Oh, inclusive. We need to add... Wait, no, wait. The error is correct. The value in the error is wrong. The fact that it is erroring is correct. Because that's wanting 7. Yeah. So in this error, when it's in the PR, so the R, the range, we actually need to add 1 because it's inclusive. So floating point, 0 to 0, 0 to 1, that would still be 1, wouldn't it? Huh? So why is... Yeah, so you have like 0 to 1. Yeah, that'd be 2 distinct integer values, wouldn't it? Oh, no. So 0 to 1 would be... Yeah, so if it's exclusive, it would just be 0. And then an inclusive would just be 1. Do we need to add the 1 then? I don't think we do. Huh, so what's reading wrong about it? So min... Range is 256. Maybe we do need to add the 1 in this case. Does make sense. But why can't I think about the reason why we need to? I guess we'll just throw it through the calculator. Right, so if you have your max value of 356, take away 100. That gives you a range of... it does give you a range, doesn't it? Yeah, but no, but it's inclusive though. You need to add the 1. Yeah, you do. So, okay. So for floating point, when you take the difference, yeah, we'll leave floating point because floating point doesn't matter in this error. That doesn't matter. Right, so let's run that again. There you go, 257. So if I change it around, so as an example, let's go to the encoder file. Yeah, so we say we're packing a 16-bit integer down into 8 bits between the range of 0 and 256 inclusively, right? That's still an error, right? Because there's actually 257 values, right? Whereas, yeah, 255 is the max value for 8 bits, right? Because from 0 to 255 inclusive is an 8-bit int. Right, so that's good. I like that. Cool. Yes, the next line that's getting an error on the parsing is this one. It's saying unpacked value is a float 64, but min. What the living what went on here? Unpacked value is a... But the min packed value expects to be... Right, okay. We clearly got some of the refactor wrong last stream there. So yeah, this one is a float. And these are also some 2 float values here. Something weird is going on. Unless... I don't know. I was saying 35, it's definitely this line. Right, so let's go to that. Parsing those packed types. So these packed types... So I passed in something a little bit weird. So... right. Then basic gets reused here. This is terrible programming. As the number that we've parsed. So this is the B8 bit. Oh, right. Epic fail. And then we pass it into here as the one we expect it to be. Epic fail. Yeah, so what we need to do is bits. Alright, just quickly change those around. So this ensures that it's a uint, since it's just signaling the number of bits that we want to use. Verify that fits into U8 and boy. Alright. Cool. Right, got another seg fault. Let's have a gander. Is that on another... Oh. Parse type. Where's type? Oh. Right, we should have put so the type could not be found. Parse type. So I shuffled some code around and we obviously remove... Yeah, so this is the error here. So this doesn't need to exist anymore here. So we can't find it. Oh. Oh, sorry. If type and right, then the else statement here says, well, if the type exists, return type. If not, cool. Okay, unrecognized type entity.enc. So if you remember, one of the first versions of this file format is we was gonna, any type that we didn't recognize, we was gonna be like, oh, it's declared externally. We've removed that now, and we've gone with a rule where everything has to be defined within the encode file that you're making, right? So this one makes all the data types that will be stored in this file will be stored in this text or binary file, has to be declared in here, and that's okay because typically you have distinct types for your encoding and decoding stuff anyway. I don't see that being a problem, to be honest. So where was I going with that? Yeah, so I guess these errors are because I guess it was quite error prone as well with this, where we maybe renamed something and didn't catch them all, like this one here, right? We probably renamed it and shortened it, and yeah. So that should be everything parsing now, and we should be back to getting a database file. Expected a root object. Right, this is our root object. Added this thing off stream. Finished off some of the parsing off stream. So yeah, hopefully that's right. This is when we're trying to save out the database file, I believe. Still not saved out yet. Oh, it's in the merging stuff. Right, this is the bit I wanted to get to next, actually, is this merging. So let's get it up and running, and then we're going to do all the validation stuff correctly, because I at least want to get a database file saved out before we start work on actually making the validation stuff all good. So type table merge is a certain because that we basically try and get the latest version and there isn't one. So this is the case when you don't have a database file yet. So I don't think we need to do a merge really. Oh yeah, we do. So in this case, where is it? Yeah, latest, right? So the other one would be like, right, get. So this is saying if we enter dev mode, if we leave dev mode, and then we'll put another comment saying like, if there is no database, if there isn't a database file, if, I guess I just want to say if the number of, if the versions equals 0, we'll just put on a version for you, and then we'll get going with that one. So where is it? File push. But yeah, what if they were in dev mode right away as well, you know? I guess a bit weird there. So maybe this should be just a general function that we have, because we've done it a few times. It's going to get a bit more if statement-y. So let me just get in there and do that. Push. So when we do this push, where else are we doing it? Right, if there isn't, use the latest version. Where we don't have a database. No, sorry, if it's not the database file. Right. Get the latest version. Interesting. So why don't we just make this as part of the push, and the other ones will basically up it by 1. Yeah, I think that's what we'll do. So if we grab this, we'll jump back version push. So we'll go, does the encoder file have any versions? Right, populate with the latest version, if not 0. And then this gets the git commit hash and stores it in there just in case we want to support branching in the future. We put the git commit hash. That way, if 2 people create the same versions, we can be like, you guys have tried to create 2 different versions across different branches, and that way we can at least solve the problem in the future if it is problematic. Hey, Lipo. And the face is getting bigger and bigger, is it? Amazing. I don't know what I've done, but I'm now bigger apparently. How's it going? Yeah, it's going pretty good. Just been, chilling with the family. It's been good. Been pretty decent. How about you? Been enjoying the weekend? I got like 5 more weeks of 4-day work weeks where I got the Wednesday off. I'm spending time with the boy, looking after him. So gonna be chilling with him and having some fun, Hey there, Wajilla. Welcome, welcome. How are you? Yes, this is pretty cool. So we should only have to then up the version by 1. Now, if the file didn't exist before, it would put it on 0. Right, when it's put it on 0, that is indeed a problemo, because you would then make it 1 on the first time you've created the database file. So, but then so what we kind of want to do is know, so why don't we put it at U32 max, and then we'll clearly know. So now this can always up it by 1 in this case. And then, so when it enters dev mode and it's not amending, right, then we leave dev mode and it's text and binary. We also want to up the version again so that the text and binary edits have different versions. Binary gets released, text is for development. So you can upgrade from the text files to the binary one and so on. Yeah, that's good. So if the database file hasn't been created yet, do you just push one on? So the thing is, if you push one on here, if there isn't a database file and dev mode hasn't been entered. Right. Something like that. So we just push on a version and all good. So I think, right, here, we've got to say, right, if gen version is equal to U32 max, put it on 0. And that way, yeah. Initialize it. Cool. So I think that's the code we needed. Right. Some other stack is not initialized. Right, it's trying to push a version on a file which simply hasn't been parsed. So that's because, right, these versions here. I wonder where we initialize these damn files. Right, we'll initialize them here before we read the whole file in and fail, basically. Right, another seg file. Let's hop in there and figure out what's going on there. Getting close though. What is this? Set target directive to specify the. Oh, the database file exists now. So it got close to finishing it, and I guess it failed halfway. Right, what's here? Type. Element type is null in an array. Did somebody not initialize the array correctly? Oh, 2. Alright, clearly that didn't get initialized correctly. What's going on here? P-type kind. Basic. This ain't no array. Ah, it's a basic. Oh. This ain't good. Right, clearly I messed that one up royally. I don't know what I did there. Return the identifier, my friend. Oh, the array string. It's good to hear. Thank you. Doing well. Implemented compute and image helper functions in the renderer. Awesome. Very cool. Exciting stuff. Exciting stuff. How are you finding working in the land of Vulkan there, Wajilla? How are you finding it to OpenGL? Is your mind blown up yet? I remember when I was learning Vulkan, my mind was like melting. There's so much stuff to be like, huh? What does that mean? So type array string just wants to print the array part, because in C, the array can be like when I'm printing out text, because basically my database file looks exactly like this file but with more information in it. So I need to reprint out array stuff, right? So I need to print out the type separately, like the element type separately, then the name, and then the array part. So that's what type array string does, is it just puts the array part out. So these are a nothing. Right, let's give that another run. Get rid of the database. Right, seem to have done it. So let's hop into the database and see how it looks. Oh, it's printed out all my intrinsic types, which I do not like the look of. But it's interesting to say the least. It's got the target in there without the targets whatsoever. It's got the version in there, which is cool. It's got the git commit hash. Is that the git commit hash? Git log. That ain't it. That just looks like a number. Where's me hexadecimals? Right, that's not good. And there's a bunch of intrinsic types. So there's 3 things to look at there already. Clearly. And then where's my magic number? I ain't got no magic. So let's go to save database. And we shall find the answer. Yeah, so clearly these are not being copied over. So in that type table merge function, clearly, yeah, there needs to be some like errors where it's like, hey, you cannot change. So we need to be careful, right? See, maybe we can else it, to be honest. Then you won't deal with the dev modi stuff here. Alright. Or you can still put the dev mode in there like that. So that will still do a push. Right, so the problem is that won't be 0 anymore. So I guess we'll put 0 here. And then we no longer have to put this if statement here when we pass the encode file for the first time. Right, it seems to be much better. So when we're doing the merge between the database and the encode file, we want to make sure that we can just copy over DST file all of the stuff, right? Like the target flags from the source file. So this is like file, GPU, CPU, and network. There's all different sort of targets. Format, which would be text or binary formats. And that's in that little hash target directive at the top. We also want to copy over the feature flags as well, just in case we end up doing some feature flaggy stuff. Magic number. Can't go anywhere without my magic number. Maybe the root type as well. Well, the root type's got to get merged, isn't it? Yeah, that's a different one. We're not got to forget about that. Dev mode, yeah, it's done separately. Right, so those at least get copied over. So the magic number, right? So we've got to talk about like these things cannot change. Like if you change these, yeah, we've got to figure out which ones we can change. How did this thing get past the dam? Boom. Cheap viewers. Huh? Yeah, it's not case sensitive. That was just a bit bizarre. He just went with the old, you know, it's one of those things where it's like you have all these complicated or expert moves that you know, and then someone with like the most basic moves just pops in and just gets by. Classic. But yeah, Twitch has actually been quite good at doing it for the past few streams. Twitch has been like, hey, there's been this thing, this looks like a, you know, one of those bot things, and it would show it on my dashboard here, but it wouldn't put it on the main chat. And it got them automatically, but that one it didn't get. Yeah, simple is better, obviously. Just cheap viewers. I've never been quite able to understand GL. I've always been on Team Vulkan long. Fair play. Straight to Vulkan. Fair play. So your mind is melting then, I guess? And hey there, Pete Riggs. Welcome, welcome. How are you doing? We want to hire viewer. And high viewers, surely. Yeah, I think we want expensive, yeah, high value viewers, the expensive viewers, not the no cheap viewers. Right, so I think we need a bit of some checking here. So inside the so we're gonna go with a rule of like you can't change these, right? If you change them, you've got to delete the database file and start again. You know, in future, if it becomes a problem, we could maybe make a way of changing it, but it might involve like bumping versions and things. that I couldn't be bothered to really sort out. Because the whole point of this file is that you would have designed it from the get-go on what it is, right? Hey, I'm making an asset file, which is all about streaming a asset from disk into GPU memory, right? Why would I want to change that aspect of it, right? You shouldn't. Yeah, so that's the reason why we shouldn't really be changing these things. So if DST file target flags is not equal to source file target flags, problemo. You know, we have written out some of the code already. So we could make a thing called print target and you simply just pass in the file. Because then that way we can make a really good error message. Code reuse. Oh yeah, file, and we're going to have another thing called files. This one gets to called F. Yeah, so that'll be good enough, as we say. Then the other one is going to be called... I started using colors? What do you mean colors? Oh, you mean like syntax highlighting? Yeah, I still had colors before. But yeah, I switched to editors, right? And I was meant to like port the theme over that I was using to Helix. But only target format, target. Wait, we're meant to do the whole damn thing. We are. Yeah. The whole damn thing. Print target file F. How's it going, the chosen one? Welcome, welcome. How you been? Right, so we're going to take this boy, right, and we're going to find where, I think it's like in the merge function, right? There's going to be some stuff going on. So let's put it here. You know, the order of functions has not really been the strongest point of this generator, but it's only a few thousand lines of code, so you can just find things reasonably well anyway. Yeah, so basically we're going to say like, hey, DST file so if the format ones differ as well, which also come from that target directive, we're going to go ahead and I guess print out some error. No, print target might have to go into a different place. Yeah, I guess we might. This really sucks. Well, we could print it out. Where does this go again? It just prints it out to standard out. Right. So like what I could do is print out 2 lines beforehand. Yeah, so I guess we'll do the line at the end. Alright, that's going to be good. So we'll do a couple of print targets. This would be the destination file. And put it into F, I guess. Oh, standard out. Right, okay, that's good. And then we'll do the source one. I did a bit of printf before, and we'll just be like, this is the encoder database file. There is a path. I'll just shorthand it like that. That'd be right. And then this one here is the encoder file. Put a couple of spaces in so it's all lined up. And then we'll do an error, like a standard one of these errors, which exits at a location which could probably be at the root. So the location is, can we make a new location? There's a function which made a new location, right? Where the crap did that go? Yeah, lock. Oh, it took in a reader. Right, so I guess we could like manually do this. Gen file. I'm gonna set the file path in here. Path, line, column. Right, I think that'll do it. So yeah, what we're looking for now here when we set these up. So parse file, file path, something like that. Discarding some qualifiers. Did more than just discarding qualifiers there. Alright. Yeah, so now that's set up in the merge function. We can simply yeah, so we'll just do like lock in it. Source file path. I don't know why I just didn't call it path, to be honest, but there we go. 0 or line 1 column. Wait, are these one based again? I forget these things. It's in the text reader, isn't it? Yeah, it's column. Column is one based as well, I think. It's in the advanced function. Where's that? Yeah, one based as well, same as line. Column 1. There we go. So we'll say like target directive targets or formats mismatch what is in the database file. So that should have everything we need there. Pass an int. No. Huh? Oh, this one's not declared in the right place. Put it here or something. I'll do it. Right, let's give that a go, see what happens. Well, no. That's what we'll... Right. Yeah, okay, we'll test that soon. We also wanted to make sure there's another one. Magic number mismatch. Can you change the magic number? I think you can. Right, I'm just gonna take a quick break and then we'll get back to sorting out this verifying these rules make sense. And then yeah, we'll test them out. So be right back. Alright, welcome back everybody. So yeah, the next thing I was looking at is this magic number. So a magic number in terms of like encoding for files and stuff. If you have your own file format, you put a magic number in there. So it's another way just to verify that the file that you're reading is indeed in the format that you want it, that you expect it to be in. There's a few things you do. You do a magic number, you do a checksum, and you do a version number, and some other little bits depending on your file. But they're the main ones. So the magic number you make up. Now, if someone wants to say change their file extension, they can maybe change the magic number as well if they wanted to. I'm wondering if we should error on this if it gets changed, because so if you have, maybe, it's a problem if they're on the same version. At least if you change versions, maybe it's not that bad, but I think we'll just error anyway, because it's a bit of a weird thing to do, right? Changing the name of it, it's kind of like a new file at that point. Yeah, we'll just yeah. So we'll do another one. So where's the magic line? Yeah, so the magic is here. That's quite easy to do, to be honest. That's why magic didn't get printed out, is because the target flags wasn't set. It didn't have file, obviously. So here I think we'll do a similar thing where we're going to say if destination file magic. So it's got to be the fact that DST file target flags and target flag file. And the magic numbers do not match. If that is true, then definitely print out the magic number for the Encoder database. This is destination file and the source file. Standard outs these will be in. And then we print out the error. Magic should be on the second line. So we'll just put line 2. Should be alright. Hopefully good enough. Magic number differs. Mismatches. Nice. Yes, so I believe we can. Oh, there's one more thing I wanted to fix, wasn't it? The intrinsic types are all get put out into the file, right? Which is not kind of nice. There's a few things actually. Right. So let's get rid of it. But at least they're looking alright. They're looking alright. I like those. Wait, these are problematic. Okay, maybe it was good that we saw these. Why are these U16s? Okay, that's not good. Let me fix that. Right, so gen type table in it. So we fill in all these. So right. I put D instead of B. B for basic, D for dimension. Easy mistake. Right, so we let's delete the database file and take a look at our changes. See how it's generated this time around. Database, reload. Oh, the version wasn't in hex either. That's a bit annoying. And why is this target printed out? Right, these are looking better now. They're the actual types. It's looking alright, isn't it? Right, so let's get rid of these intrinsic types from the printing at least. We don't want those in the database file. Because we're never going to add or remove new ones, I think. And if we add new ones, it doesn't really matter. So magic seems alright. Target's missing its stuff. For some reason. Even though we should have copied it over in the merge. Bit confused on that one, to be honest. And this is still not in hex. Right, so U there instead of X. Yeah. Right, so that's that problem fixed. The other one was we shouldn't be encoding out intrinsic types. So we should start this on intrinsic type count, since the first lot of them are intrinsic types. That's the order we put them in. So we'll start on that one. So we won't encode those out. And then the other problem was that the type wasn't getting... the target flags weren't getting printed out at all. But they must be there, right? I don't know, let's have a look. So let's put a breakpoint in. Because we definitely copied it over. Let's delete the database file again. Oh yeah, we got the trap, good. Let's go to GF. Ah, the database file got created. Delete it. Right, so here we go. What's target flags? File. Interesting. Oh, shoot. I did my iteration wrong. This gives me the bit index that's set, obviously. Right. So yeah, if you guys are not familiar with this sort of code, basically we've got a bit flags, right? 0, 1, 2, 4, 8. Yes, this enables bit 0, bit 1, bit 2, bit 3, right? So we can enable these different bits, right? So what I'm doing here, this for loop, it just basically iterates over all of the bits. But it doesn't iterate over all of the bits, it iterates over all the bits that are on. So this is a get a least significant bit index using the count trailing zeros, or on Windows bit scan forward. That translates to a single instruction on x86. Probably on ARM as well. But yeah, then we get a bit index. So I need to do one shift left to turn it into a bit flag. Right. And then after you've done that one, we take the bit flags and we remove the least set bit, which is basically ANDing itself with itself take 1. And then that will remove the least set bit, and then we can carry on around again and keep iterating over it. So it's pretty nice. Yeah, I just didn't do the shift left there. So that's cool. So let's delete the database. Wait, I got the breakpoint in there. So let's delete the right. Got a success. So let's take a look. Reload. Cool. Target file. Nice. We meant to get the text binary thing in there. And this is still in damn. Oh, what the crap's going on there? And why is... Right, we're still getting... Ooh. Doesn't that look funky? Right, sort this out. So, version. Okay, no, sorry, these format flags. What the crap is going on here? Right. We better copy paste errors there. So that's probably fixed now. Cool. The other one was the version. What? Told it to print as hex. Oh. Right. Version number is... Okay. Version number is decimal. Commit hash is hex. Whoops. My mistake. So that's good. Go back to the encode database file. The other thing was we still got some intrinsic types in here. That's because we do sort of recursive descent when we go and print out a type. Or we're going to save that type so that we declare them in order, in parsing order. So in the save database file, we go over all the versions, put the version down, go over all the types, starting off the intrinsic types, save declaration. Save declaration is going to go over all the fields inside of a structure. What is this code? If type kind is equal to a structure or a union. I'm sure there's a good reason why this was this way. I probably refactored it. Oh yeah, the code definitely got refactored heavily, but yeah, just probably, I don't know, something to do with that, right? But yeah, if it's a structure or a union, go into here and go over all the fields and call the same function we're in again. So we can... Yeah, call the same function again on the structure field type. So it'll come back in here. So if it is not a declaration. Oh. Right, okay, so... Right. So some of those intrinsic types would have been a structure as well, wouldn't it? Yeah. Right. So I guess so, right? Only enums and struts go here, so that's why there was the else statement. But anyway, this is a bit safer. Okay, so we also need to say, right, if this thing is an intrinsic type. Type is intrinsic. Is intrinsic. Then don't serialize it out into the database, basically. Type. Where are we getting the type table from? Well, call it a table. Right, table type return. Right, don't save those boys out, please. There we go. And let's just go around here. Table. Oh. Table. Gen version type table. Take the address. And there we go. So let's give that a run. Wait, delete the database. Look in the database file what we got. Give it a reload. Alright, things look a lot more sensible now. There's not a space here though, so that's not going to parse up. Getting close. So when we do that print target, space. Right, so we've got that delimiter in there now. Magic number looks alright. Bit of magic in there, you know. Guess we're alright there. Version. You know, maybe you don't need the extra new line there, to be honest. How do we get rid of that? Print target. Let's get rid of that new line at least. Cool, version number, that's alright. It's not printing out the underlying type here, that is a bit weird. Look into that. So we've got it here as TU. Why didn't that get passed? So in the, oh sorry, why didn't it get printed out? Context aware printing. Oh, did we not? Okay, did we not set the context then? Don't think we did. Oh, we did, it's right here. So where's the U in this? Is underline type not set anymore? It must be. Yes, initialized and then seems alright. So why don't we get, oh, right. Okay, so we didn't handle the U case here, so it just did nothing. Right, so we've put this extra switch statement in here because we did something different, but now we don't need it. That's alright, isn't it? So that should print out that properly now, so it's good. Let's go back to the database and find anything else that is going to be different. So we've got to really compare. It's just a bit of v-split with the source logic test.enc. Right, so this is the file on the right hand side that we parse up, and then we've got the database that we're saving on the right hand side, which preserves the history of these encoded structures. So they seem to have, they should copy over right, but they should be more explicit. So obviously they've got these in here. We've already tested this code before, so I'm not too fussed about overly testing that. They've not got their keys in here though. The keys are missing. Keys are important. We need to preserve the keys. Yeah, the floats are printed out. Yeah, maybe that's going to be a bit weird. Maybe I'll be right. What the hell? Oh, packed types. Right, printing packed types have got a bit of a problem then. Right, so let's look at the printing a packed type because we added enums, support for enums. So maybe we added support for enums. And we said you could change these so long as it's text, isn't it? What was the rule again? There's a rule. Alright, versioning, this is it. So for text files, you can change pack types, min and max values, right? Because they're only used for binary, so you can just change them if it's only exporting for text at that point. And then the next version will be binary because that's what you release as. But if you're doing binary files, you cannot change the packed min max values, and you cannot add and remove. But you can rename enum values. That's it. Because if you add and remove enum values, that could change these packed type min and maxes. That's correct. So because you can't add and remove enum values, we could probably just encode. We'd have to encode the exact values in there, to be honest, as well. That's correct. So I think what we'll do is go to that enum. Sorry, when we print out the packed thing, so it's like save type decor. Enum. Yeah, so we need to add ones for like the other fields and that. That's true. But what's this? Yeah. Type kind, type identifier, open bracket, every field. Field. Right. Field basic value, field identifier, array, right? Because arrays go after then, default value if there is one. So this B, let's go to the context where we're printing. It's the base type string. This is where it prints out those. Right, this is problematic. This should have called this one. Right, that might be problematic. Hey, Clarissa. What's up? Yeah, doing good. Yeah, just trying to work on some of the validation stuff today. Yeah, just getting the encoder database file correct, because since we finished off the parser now, so just be working on the verification code to make sure that all the rules that are defined in this specification actually are in the code. But yeah, doing good. Just had a pretty chill weekend, really, to be honest. Not done much. Just been chilling. How about you? How's things with you? Oh, where'd the music go? Yeah, so if you got a type string, like packed isn't gonna get the proper ident, right? So packed kind of wants to call the basic string one and go do this one. Yeah, these should call this one here. So that's problematic already. And then this one's putting a string out. It's using the underlying basic type. Dang it. It needs to be using whatever the type. So it could be an enum. So if it's an enum, so I guess we could concentrate. Oh no, we can't because it's a dem. Yeah, I guess we'll do another string. Ooh, let's call it base. So if the packed type is an enum, then just use I don't else basic type string core string C basic type strings basic. Right, so this will have to go into here and have to like change that. So int casted base size base data. I have to copy that and give that the old paste. Cool, so I think that'll fix that problem. So just hop into that database file. Let's give it a delete the database. Give it a regen. Give it a reload. Start uni, so I'm a bit miserable. Oh, okay. But I'll get over that interesting stuff. Can't say I saw people do data management like this. I need to catch up a bit. Yeah, I didn't really. Yeah, it's nothing I've really seen anyone else do. Yeah, it's quite a system to design. I guess it is kind of closest to say maybe something like a flat buffers or a protobuf, whatever you want to call them. I forget what they're called, to be fair, because I've only really briefly looked into them. But they're a data description format that you declare in your own in your own sort of language, and you generate code. So yeah, stuff like this already exists, but this one's a little bit different. It's got like a database file and other bits, I guess, about it, which make it different. But yeah, I think I'll do a video. Save yourself watching 13 streams because there is, yeah, I was thinking going one direction with it, and I changed my mind when I did that those design streams. Maybe you could watch those if you want to catch up earlier, but I want to do I'll do a devlog basically going over it in a more condensed version if you want to wait till that one. Yeah, because I think it's worth documenting. But yeah, cool, uni. I didn't realize you're of age of uni. Cool, interesting. Um, yeah, is this your first year then? Or is this like your second year? That space has been printed out correctly. We've got this correctly, the underlying type. Nice. These are looking alright. These are not getting those keys or anything at the moment, but that is definitely printed out, which is pretty good. If it's an enum type, we did say that we didn't. What do we do with enum types again? So this is when we pass the pack stuff, right? If it's enum. Right, enums it could pass the actual name. Right. You can do ranges, yeah. Yeah, we won't do the shorthand in the database file that pass the full-on thing. That's cool. But the problem is when you pass it back up. Yeah. We'll do we'll do a separate print code because it's a bit problematic. So instead, we're doing this. So I think these kind of have to get undone a bit. But yeah, we'll say if it's equal to an enum. We can print out the name of the enum, the number of bits, 2 strings. Got to do the long strings, unfortunately. But yeah, they'll be in min type packed min value identifier, right, min max. So here we'll be able to do those. Min size, min data, max size, max data. Cool, so the else statement will do this switch. So this is when you do just integers and try and pack those down. And then we can restore back to the more simple approach, which is this one here. Right. Nice. Yeah. No, I'm gonna do that more often now. That'd be cool. Right. Yes, that should be better. All right, let's delete that database file and go again. Second year of master's degree, so I'm a bit of age, I must say so. Right, 23. Yeah, you're getting there. That's cool. Yeah, you're of the age where you're like, you know, still too young for people. Yeah. When you get to the age of 30, you're like, that's like peak age in the workforce, and then after 30, it's like old. Yeah. It does suck being young in the workforce because you get some real mean people who just like treat you as just some young guy who knows nothing. But yeah, it's cool. Masters. I didn't realize you was going that far with it. Are you looking at staying on and doing like research and stuff at universities? Is that your plan? Because I know some people like to do that sort of stuff. Right, so let's regen that file. Let's have a gander. Nice, so we've got these in here now. So that's pretty cool. So it goes from person to mouse. It's all explicitly encoded in there. Sweet. Right, so we should actually get all the directives printed out in here as well for all the fields. So we'll quickly do that next, I think. Everything else is looking pretty cool. Yes, the directives. So save type. We've done like an is hex is removed. Not sure if we need the removed anymore. We'll see. Right, it says tag and there's key. So if key fprintf dot star s. Why could I have done it? Wait. Value identifier, and then I can just set generator enum value equal to key. That's it. So that's those tagged unions basically. Well, they're just unions, but you can put the tag on it if you're in a text field. Sorry, if you're saving that to a text file, you need it. For tag, it's a structure field. With the tag. So I can then say field identifier with tag. Cool. Let's pop over to the encoder file and see if we missed anything else. Yeah, the root also needs to be on there as well. So if type is root, structure is root. There also is packed. Let's get that sorted out as well. So packed. Oh, okay, that one was root. Right, root, packed. Nice. I don't know if there's anything else really. Yeah, no other directives there. Enum values don't really have directives either, I don't think. Yeah, looks like that's all serialized out. That's good. Right, so let's reload that one and have a look. Boom, 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 boom. Oh, you get that feeling you knew that. Fair enough. Oh. Yeah, it's a plan for now, but not because I like it. Uni is mostly garbage, but I'm not ready to change things in my life drastically, so I'm following the safe path for now. That's fair. Yeah, the economy isn't really in a good place at the moment. Safe is typically a good option right now, I think. Yeah, no point making risks at this point in time. Plus, you know, I guess you're working on your side project and stuff, so maybe your side project can get to a point where you're like, you know, now I can take a little bit of risk or do it on the side. And if it takes off, it takes off. So, you know, that could always be a way out, if you will. But yeah, that's cool. It's interesting. Maybe you can, yeah. Maybe you can find something interesting to research. You know, just make sure you don't research moving garbage collections to the GPU like I saw someone do. That one was crazy. It's in the University of Kent as well, which is the one I was looking at, and they turned me down because I didn't know Oracle database. And I was like, but I've done MySQL, it's basically the same thing. And they're like, just was completely silent. My time at uni. Alright, I think that's looking alright. So, let's delete the database file, give another one of them. And, do a cheeky reload. Right, getting the keys and the tags printed out now. Nice. So now it's time for some verification / validation / yes. So this is where the whole sort of encoder system comes into play, where if you make edits to the encoder file, it checks in the database to make sure you haven't gone and changed things you shouldn't. And then it will tell you if you need to put it into dev mode and then actually make some changes, and it will. So there's quite a lot of little things that we'll catch. So I guess let's get going to it. So these basically look the same at the moment. So go into the logic. Right, here's the one on the right is the one that the user edits. The one on the left is the one that is the database, right? I kept them the same because why not? We can merge it, we can, but it's just more explicit, the one on the left. And when you have more versions, it retains the versions if you would like to keep them. You might want to not upgrade and then it just chucks them out because you don't need them anymore. But yeah, so that's basically, so I'm glad that's all come together there. So where this validation happens is the type table merge function. Here's the high level overview. We parse and generate by parsing the two files, first the database, then the user's encoder file. Then we merge the encode file into the database, then we save out the database or the new database. Right. So in the merge function, we simply do the validation. So I've already done some of it today, obviously, but we check to make sure that if these two things change, then it's there's an error, right? But there's quite a lot of. Maybe we try to run it again and see what happens. Expected enum strut version, but got version. Right, so clearly my version encode, so it parses the database file, and where it does that sort of hash version parsing, it's clearly wrong. So it should have parsed that. Ah, you bugger. You know what it's done? Compare char and then it would have skipped it. Right. Let's see what it's done. Just parse the previous dev directive and it skipped over the character. It's another reason why I should have done the tokenizer. Right, so if I peek it. Right, you know what I'm going to do? It's quite easy actually. I just need a hash dev anyway. So peek until, and then chuck that in there. Get rid of that line, and that line. Easy peasy. So I think we'll do that for the rest of them. So target. Don't know why I didn't do this first. Target. So if we've not found it, it's an error. The other one was a bit of magic. Bit of magic. Oh. All right. If we found some magic. Yay, magic. But yeah, so, this is interesting. These advanced by, yeah, that's right. So, hang on a minute. Right, so you would have compared that. Yeah, okay, that's going to work out now. That's good. Right, so give it a run, see what happens. Right. Expected new line after argument version. Alright, what did I do? This is where I should have read a whole line rather than doing it manually like this. So is there like space characters in there or something dumb like that? No. So it would have parsed up. That's interesting. We've not actually tested this code out before, so let's put a breakpoint in there and take a look. Right, so skip some white space after the version. That's all right now. Yep. Gets the version number 0. That's correct. Next one. Git commit hash string. Right, seems alright. Oh, I should have skipped some white space here. Okay, that's why. The problematic thing. That'll do it. To follow. Hey, what the crap's going on there? We've probably got like an E range error or something like that. All right. Oh no. Yeah, but what was the endpointer then? Endpointer, like... Oh, it says base 10. That's why. 16, please. Invalid suffix. So... Where am I doing this? Oh, 38. Line 38. Okay, so it did do some parsing. 38, what we got? Ooh. What? Does it know it's an enum type? Oh, so we've not done this type of parsing yet. Because it was done implicitly in the other file, it just didn't have this. But now we're doing it explicitly. So when we parse the types, in here we say if it's a basic type or an enum, and you've got the bracket, it means it's a pack type, so we start parsing it. There's a function that we call, which is called like parse pack type bound, and that's one of those arguments, the min or max one. So in here, if it's an enum, so I guess the type that we're passing is not an enum. Yeah, what a wally. So type in here. So this, the word type there is super like unambiguous. So we need to say, oh sorry, super ambiguous. We need to say, we need to call it unpack type instead. Unpacked type. Hey, Ray March. How are you? Welcome, welcome. Right, so that one here needs to, type packed, unpacked type. So it's clearly just a bit of a incorrect argument that's being passed in. Now we've got a circ fault. Fine with op array length. Interesting. Let me give a refresher on what that is. Length for runtime array. Oh. Like, why does it need a storage pointer? So I just used. Wait, do I even have these? Apparently not. Hang on a minute. Yeah, I don't have them. Yeah, I just have array. So what I like, are you doing like a structured? Are you trying to do like a storage buffer? So in HLSL, right? No. Yeah. So in HLSL, so okay, in GLSL, they're like, you know, you get a bit of a header, and then you can have a variable length element at the bottom. So you could be like, hey, I've got this thing called like lights, and I can have my lights type with lights, and then it's a runtime array. So in HLSL, their storage buffers are called structured buffers, and they don't support this header part. They don't support it. So what I've done is I've just done it the HLSL way because it kind of makes sense, right? You just have like an array of type T in this case, which is light, and then that solves the problem. Yeah, so I just treat it as like, just get rid of the header part. It's interesting, right? But it's not really that useful. And that's what I do in mine at least. Um, yeah, so like, if you wanted to do that, you would just make two types. You'd make another buffer which has the header stuff and only has one element in it. And then you have, another one which has the array part in it. That's if they wanted to emulate that, they would do it that way. So it's not the end of the world. Yeah, so and that's probably how. Yeah, and like you could even like in the Vulkan maybe allocate it like that as well in memory. So it's not really the end of the world. Um so yeah. And I guess that would get around your problem. I don't really know what that. Would you must specify? Why must you specify this length of the runtime array? A literal. I remember. Oh, right. So in this case, it would always be. Wait. Yeah, offsets where the array starts. Yeah, but I didn't need to specify this. So maybe that it defaults to 0, maybe? I don't know. Well, mine's always 0, I guess. Or the length of this array type. Do you have to set this? Anyway, I'll just make it infinitely sized. Maybe you can specify it. Oh, it's an immediate ID. I don't know. But yeah, hopefully that helps solve your problem. Excellent. I'm glad I helped solve your problem. That's cool. Right, so why didn't that fix the problem? Right, okay. It's not solved. I just want to support it all the way. Oh, with the header. Right. Okay. Yeah, just be careful when you export to. Do you export to HLSL? Because that might be a bit funny to do that. Right. It's messy because Rust strut and RPC and whatnot. Yeah, I know Rust has to reorder its stuff. Yeah, the header thing really just I never use it. Like people might put like a count in there or something, but you could just get it from another buffer. Not the end of the world. Yeah, where I got this damn seg fault? What the going on here? Alright, basic is like pretty big. Oh, did I? Why is the basic pretty big? That's interesting. What is that then? Oh, have I not set the unpacked? The unpacked type gets set here. Right, anyway, so enum underline type. Yes. Right. And then it's a problem. Do we? Okay, we passed the number and overwrite the damn basic local variable. I guess this is why people say like, oh, you should const all the things. Right. Or we could just name stuff better. Either one will do. Yeah, anyway, so that could just be unpacked type. Save some characters there. So in this function, we're doing something really dumb. No. Yeah, we're not initializing this. Ooh. Sure. So this would be something like. Wouldn't this have a bit of a problem with? Unsigned and signed stuff? Because the basic comes from whatever the underlying type is. Yeah, the error is going to be a bit weird. Anyway, basic equal unpacked type enum underlying type. Value equal found value. So here that'll work correctly, but what we need to say is if equal type basic class so the problem is you could have an assigned integer and use unsigned ints as the range or something like this, and it will error. So if we say if they're equal to a float and then check if they're not equal, then that will be like, well, if they're both floats, it's okay. If they're both not floats, it's also okay. Yeah. Oh, that was a bit of a weird one. That should fix that problem. Right. In the database 38, it's the same line in it. What was it? It was like 46. Oh, we didn't parse some white spaces. Let's get on that one. Skip some white spaces. What's going on? Oh, the closed brackets. Close brackets. There's some white spaces. It's right there. What? Alright, I wonder where the error is. Since the whole world is using SPIV now, I'll probably never care about it, HLSL. No, but you do, because DirectX will not support the header in DirectX 12, basically. That's the problem. I think so, at least. You have to do some checking. What do we do as exits? It's like exit reader error, I think. Right. It's good. Verified, identified, type bound. Ooh. Did it pass too far? Ah, did it pass too fast? Why? Yeah. Whoopsie, another reason why I should have tokenized it. But it was just quicker to get going if I didn't bother around a tokenizer. Just wanted to go. Right. The strength field type mismatch. Yeah, so parsed it all okay. Now we're just dealing with actual like validation errors. So yeah, I guess we just should start working on these validation errors and make sure that actually all makes sense. Maybe we should fix this one actually, because it's saying type mismatch. So clearly the way it's copying the types over and preserving them or something is not happening correctly. So yeah, and that hint is wrong as well. We didn't put stuff in dev mode like that. Yeah, but you can still export Spivvy and just throw an area of the target API as DirectX. Because I know that since I did the whole pipeline thingy. Right. Oh, I see, right. Yeah, you could say you can't have a header. I see. Nice. Yeah, that could solve it, I guess. I would just go the simple approach and just keep it all the same. Personally, that's fair play. That also works. Just supporting less features that way. Um, right. So that's in the type table merge function. So yeah, we do the merging after we read the two files, the database and the encoder file, and we do the merging. So in here, we basically get the database latest version, and the encoder file doesn't have multiple versions in it. It just has the latest version in it. And we then go over all the types in the source table, try and find them in the database, and make sure that we are simply, or that we are that we're not changing types and things. And there's rules. These are the rules here, which we're going to make it obey. So these are going to be changed since the last one. Like if you're encoding into text or binary, there's some rules we've got to follow. Okay. That's cool. Right, I'm just going to quickly get a drink and then we'll get cracking on this. We're going to follow all these rules and yeah, check some errors. Right, BRB. Right, so welcome back everybody. So yes. Where was we? So when we're merging from the encoder file to the database file, we've got to follow these sets of rules and make sure they're all obeyed. So So we're not in development mode. For text files, we can do these things, but we cannot do these things. And for binary files, we can make these changes, but we can't make these changes. So we'll get into those as we do them. So we go over every single type in the encoder file, and we try and find its version in the destination in the encoder database file. So right, I think we should just follow this code and just make sure it all makes sense. And yes, this all makes sense because we've done this. Right, so if it doesn't exist, insert it into the table, into the database, copy it over. So we saw this working in already because we made the database file and it works. If it's not an enum, so it's a union or a structure, this is problematic because this could actually be an intrinsic. Oh no, because intrinsics will already exist. And you can only declare none. Wait, but this could be an array. Yeah. So let's do it properly. If strut or union. Yeah, but you got array types as well, and this is going to like translate them over, isn't it? Yeah, translate the types over. What about arrays? Because arrays can have element types of. Yeah, so we did a translate. Yeah, we'll do arrays as well. So realistically, So maybe if it's a structure or a union. I guess you need to do another one where you say if it is an array. Huh. If it's an array type, then translate the new destination type. It's got a array part and an element type in there. And we need to do is translate it over. So all translate does is it takes like the type pointer and it goes, well, if it's a basic type, swap it out for the one that's in the destination type table. So destination is the database, source is the encoder file. You have two different type definitions which mean the same thing, so you're basically saying swap it over for the one in the database. And then if it's a structure, we take the identifier and just look it up. If it's an array, we just make a new array and we translate the element type. Yeah, I don't actually, this one is fine because you don't get. Right, an array is not a declaration, we would have skipped it. Okay, I keep making that mistake. So we don't need that. That's good. So it's all parsing over okay. So then we, after we get the destination type, yeah, so if the destination type doesn't exist, we make a new one. We insert it into the database type table and continue. Right, so there's no validation. So now there's some validation. If so, you're going over the source ones, the ones in the source type table, and you are you find the destination type, right? So if their kind differs, so one's a struct, one's a union, we make that error here. The error we was getting was the fact that the type mismatched on the field, and that's very strange because they shouldn't be mismatching. Maybe it was the strength one specifically, so we could look at the strength field and see, but strength is okay, is one of these packed ones. So I guess, yeah, some of this packed stuff hasn't been translated over properly, I think. So we can look at that. Right, so packed actually has more things now. Oh, no, the way does the comparison. Yeah, for packed is a bit different. Right, it's interesting. Some of this stuff has got a... where's the comparison? Yeah, so type equal on it. Yeah, so type equal, it used to just be like, just data in there, right? But now it's got pointers in there. So we can't really do a mem copy compare anymore. So realistically, we need to... What makes these identical is that the unpacked type is also identical. And then... No, I think we could be able to do a mem copy if... Because this would be a... Sorry, a mem compare. Because this will be resolved to the same pointer. And these should resolve the same pointers too. Yeah, but you really got to translate all of it. It's really crazy. What could we do? Yeah, you have to... Yeah, we have got to translate them properly. Yeah, so if we did the translate properly, it should just be able to be mem compared. So let's just do a proper translate. So it just returns the type when you translate it. So realistically, you've got to do like... Let's get that packed thing. Just bring all the things over. Right, what things we need to change? So the pointers basically need to be updated properly. So all you need to do is say type. So yeah, it's already passing in the destination type, isn't it? No, we need to make a new type. Entirely make a new type. So this new type is a packed one. And we'll just copy it over, right? Just do a direct copy. And then we'll change all the little bits about it. So the pointers I need to change the unpacked enum value min. That is, we've got things, we've got search functions. These are in type find, or I think we've just got one called find value. That would probably do it. The problem is these are just below here, so we've got to move these things. Our type table find value, that's the one I wanted. So type table find value just takes in an ident and gives you an enum value back out. So that's how we'll translate it over. We'll just essentially say, hey, look in the database file for that same identifier. So unpacked enum value min dereference ident. Now you only really want to do this if it exists, right? Or if it is an enum. If new type unpacked type. Unpacked type kind is an enum. Same with the max value as well. Mess that one up royally. Cool. So those are translated. The final one to translate in this case is the type itself. So packed type translate destination type table, source type table, new type packed unpacked type. Cool. Damn, this guy rocks. Wait, this guy, Nick Johnson. Yeah, he jams pretty well, doesn't he? His yeah, he's got like a few good albums I really like. Yeah, I see he spelled his name, Nick Johnston, without the E on the end. He makes me want to learn guitar, man. It's one of the things I want to do at some point in my life is learn the guitar. It'd be pretty cool. Like for the longest time, I wanted to do it because I've had quite bad problem with my fingers because I type a lot, and I had a really poor diet. But now that is kind of going away, and plus I exercise a lot now, so I think like it won't be as bad. I think that will do. Yes, it was translated over this point as the basic type is fine, the values are right. Yeah, then the mem copy should just be okay. So I think that'll fix the problem that we was encountering with these damn errors. Merge. Okay, so I guess why don't we just try and run it and see what happens. Right, the strength field is still a mismatch. Yeah, why is it a mismatch? So if it's a structure, so it translates over the source type and checks for equality. Like, come on, man. That's where it fails. I guess we can do a good old breakpoint and take a look, because that's strange. That's cool, go for it. I did some piano lessons when I was little, not my thing. That's, yeah. Yeah, well, yeah, it probably won't be for a while. Though, some point in my life. Yeah, I think I'll be quite good at it, but like after a good while, obviously. But yeah, music is a whole other can of worms, isn't it? But it'd be something I can do where I can just sort of like practice it downstairs with my family, whereas with like programming, it's like a thing I do here in my office. Right, merge type packed. Ah, floating point values. My friend floating point. But is strength float? This is where you're gonna say I told you so. No, okay, it's not float, obviously. Right. That could be a problem though. Mem copying with the values not being exact. Sorry, mem comparing with the with the values not being exact. That could definitely be a problem. I can see that. And the other one was destination structure field type. Right, so these are the two ones which are supposedly not identical. Right, the pointer's different. Right, of course it made a new pointer type. Wait, is that right? Because if it's an enum, they should always point to the same thing. But it's not an enum. Uh... Oh, I just returned type. I didn't return the new type. Well, anyway, I expect there to be problems with the floating point. Oh, sweet, it ran successfully. Right, so I was able to run the error checking code successfully that we currently got installed, which is kind of wrong. But at least we're able to run it, parse the database file, do the merge code, and it runs fine. That's good. Okay. Oh. Right. So we go over every field. We translate the field type from the source database to the from the source file to the database file. Then we check for equality. If they're not equal, type mismatch. Excellent. So this is like they've got to follow some rules. So I guess there's two classes of rules, right? One is for text files, the other is for binary. So at the top of the file, you say like, hey, I want text, or hey, I want binary. You say, so you can just have binary, you can just have text, or you can have both. When you have both, it means that you're only doing binary when it's in dev mode, and then when you make your changes, and when you want to release you remove dev mode, and then it will up the version again. So I guess I'll say it again one more time, but it's a little bit clearer. The whole design of this is you have your text files for development, binary files for release when you have a text and binary mode on at the same time. You'll be at version 0. You can make all your changes to this file in text mode that don't cause any breaking changes, which are following these rules here. Like you can add or remove fields, but you can't change the types of fields. And then when you want to actually make the binary file, you put it into dev mode. So when you want to actually do a release, that'll up the version. You make your necessary changes to the file and everything. Test everything works with the upgrading, and then when you remove it, it will upgrade the version again. That only happens for text and binary files. So it means that you can have text files on even numbers, binary files on odd numbers, and then that way you can upgrade from text files to binary files, or binary to binary files or whatever, right? No problems there. So what we need to do is identify what is following the text rules and what is following the binary rules. So basically, if it's got text and if it just has text enabled, then it means you follow these rules. There is like a where's the because if you're in dev mode, you will be able to break any rule for binary, right? With that text and binary mode. Whereas if you've just got a binary format for that encoder file, you will need to what you need to do. Yeah, you need to put it into dev mode to make necessary changes, but you would have restrictions. So we need to, where is it? There's, yeah, dev mode thing, here it is. Yeah, so if you're in dev mode, you can basically skip everything by just translating it all. Okay, so this is where the rules will happen. So we want to say like Boolean is text validation. Oh, okay. Maybe let's do this. Destination file, format flags, and format text. So we could say like use text format rules even if binary. Even if binary is active. Even if there is a binary encoded file. Binary format 2. This is because binary with text / binary when using both text and binary at the same time. Binary format is only is only when dev mode is active. Thus, the rules only apply for text in that case. Outside of dev mode. In this case. Right, but you still have a binary mode, right, when a file just supports binary, so there is like an else if DST file format binary. So we've got these sort of rules to follow. I think that's it. Okay, so I guess we'll do the binary rules because I think they're easier, and maybe they sort of I don't know. There's something to do with this here as well, it's a bit questionable. Right. Okay, so for binary mode, the rules are you can change stuff, you can rename fields. How would you detect a rename? Oh, it's all about them being in order, isn't it? That's what it is. It's all about them being in order. So you should first check if you've added and removed stuff by simply if you cannot change types. Right. So maybe we'll put these. So I think what's this? Okay, so you can add and remove structure fields for text. So this is saying we haven't found. Has a new field. That's only for structures, isn't it? In the old code. Or if type is a strut. Something has been reordered. Or something like this. Right, so we're going to have to do something. Okay. So if it's a binary file, we're gonna have to go over all these fields one by one anyway. So you know what? I think we should make this statement just a bit wider in terms of what it catches. So so all of this code here, I think. Will kind of be for the text one. The way we do the binary would be different. So has a new field. Yeah, but we're looking over them in order, so I don't think we need this bit set thing anymore. It was interesting though. Thing to have. So it means we don't need these rules anymore. Where's the bit set declared? Here, we don't need that anymore. Because you can add and remove fields without a problem with text. Okay. Seems legit. So I guess let's do the one from scratch then. So the first thing you want to do is take the fields count, and if it differs, we want to report an error. So if is not equal to source type struct fields count, report a lovely error and just bail out of there. Should be nice. So the error is you cannot add or remove fields. So structure identifier is missing. Yeah, so it used to be a little bit better where we say like, oh, it's missing this particular field. But yeah, now I guess we just say like, so you have to go for them in order anyway. And then you just say, oh, there's a type mismatch. Yeah, so I guess we'll, okay. Has a different number of fields. Has this many fields, but in the database, it has this many fields. Since you are encoding to binary, you are only encoding to binary. You'd like to change to add and remove fields. Put the file into dev mode. This will force a version upgrade, and then the hint would be dev upgrade right at the top of the file. Cool. So I guess that'll work. We got to put the type. We put the format type in there. No, we need to do that. Gen format type equals source type. Nice. So the next thing we need to do is actually go over. Now we know they are equal to each other. We now need to go over the two types, the source and destination, and we need to then Oh. We need to make sure that the types match. There's a few rules, right? So we can rename stuff. That's okay. So we don't really need to check names. But as long as the types match, and things seems to be in the same order, all right. Because it's all about being binary compatible with each other. If it's just a binary file. Maybe I should write that. Yeah. I'll put that in the documentation file. So when data is coded as binary, no, that's all right. Okay, so we've done that here. We need to translate the type over, check for equality. So this whole line here, the type mismatch. So field fi type mismatch. This is where we need to probably do an index instead. We're going to say like field at index this. Type mismatch in the database, it is a this. Yeah, I think we'll do a bit of both, I think. We need to do the new hint for dev mode. Dev mode is per file now rather than per object. And that will be field index like so. Bearing in mind it is a for loop, so it'd be an unsigned pointer. Yeah, so that would be a good error check there. That's good. The other one is for yes, you can't add or remove, change the type. Yep. And change pack to min or max values. Is that the same as changing the type? Huh. So for text files, you can change the min and max values. That's okay because it's not a binary file. That's when the packed types are used, right? Whereas in text, you just output it as they are in text form. Whereas you can add and remove fields, but you can't reuse a removed field with the same. Sorry, yeah, you can reuse it, but you can't change the type. Reuse a removed enum value of a different name, yeah. So you can't change the type basically on a you cannot change the type on a structure in text. But you can change the packed ranges, which is kind of like changing the type though. So for text, we've got to be careful this equal thing. We might have to say equal binary equal text, where it has a bit of more of a relaxed rules here. Right, for here you just want it to be the same. Yeah, so actually we need to say like So if it's text, you want to do a manual sort of compare. You just want to make sure that your types match. So you just want to make sure that your type, it doesn't really matter, right? You can change the number of bits, you can change the number of bits as well, it doesn't matter. Right, that needs to change. So the equality comes from that. Nice. So we just got to change the fact that we're calling this in a few places. Alright. So in this case, this would be text. In this case, it's binary. Cool. And then in the documentation file, where we write that, pack type, bit count, bits count, that can change. But it cannot change for binary. Right. Cool, that's good. Right, so I'm glad we made that change. Okay, so the next thing we need to be aware of is that we cannot change... It's just the types, right? For the binary files? For structures? Yeah, and you cannot change the packed. But that's all checked in the type equality thing. That's good enough. Right, so that's actually dead simple. We check for... Yeah, so that'll be ABI compatible then. Cool. Pretty good. My main concern though is that are we getting... We've got to do... Right. So for the text, for structures at least, Hey Driver State, how you doing? Welcome, welcome. How you doing, sir? So text is a little bit different, right? You can add and remove fields. But you cannot change the types. So I think a lot of this stuff, the way it worked, is probably quite similar to how it was before. Just change, let's sort out these endings and then we'll deal with the logic. Good, thanks. Awesome. Yeah, doing good. Getting pretty tired to be fair, but yeah, not doing bad. Yeah, just been chilling over the weekend really. Just been spending time with the family, you know. Yeah, it's been good, having fun. Still got I got like 5 more, is it 5 more weeks? Yeah, I got like 5 more weeks of Wednesdays off. So I'd be chilling with the boy on Wednesdays, like just playing around. It's getting close to walking actually. His I've been holding on to his hands and he's been like moving around with me holding his hands. But sometimes if I let go of his hands, he's just standing there for a bit and then he just drops down because he's scared. He doesn't like falling. So yeah, I think he'll get close to walking soon, which is great. He is a year and 2 months now. So he should be walking by now. He's just been a bit lazy about it. But yeah, doing good. Doing good other than that. Yeah. Just working on this encoder system. It's getting closer and closer. Currently working on the verifying that all the rules make sense according to the sorry, we're verifying that the rules that we've already thought about in the in this specification here actually are in code form. So we get proper errors if we make changes to the encoder file, and we shouldn't make changes unless we put it into a mode where we can make changes which will up the version. So yeah, just working on that right now. So yeah, if we're in a text file, if the field doesn't exist, right, whereas the binary files you couldn't have fields that didn't exist, so you checked for the matching number of field counts, and then we went over all the fields, make sure all the types match. Because you can't change it at all because it's got to be ABI compatible. API and ABI compatible. This time we can go over all the destination fields. Look for the source field, the matching source field. If there is no matching source field, we can mark it as being removed. We got to keep stuff actually and mark it as removed in the database because there's a rule. And the rule is you cannot change a type of a field. So if you remove it and then bring it back with the same identifier but with a different type, that's a problem in a text file. Because in a text file, you can imagine we already have some data saved out with that name and it's an integer, but you read it as a float. That would be a problem, or read it as a structure of some kind. So we have to retain it in the database with a removed flag on it. So this is, a lot of this code is going to stay the same actually, which is pretty cool. So we can't change the type. We can't change the default value, is that a thing? What did parse Henry do? Alright, parse Henry said you can change the default values. Why was that, parse Henry? So if you change the default value on a text file, right, the field doesn't, for cases when the field doesn't exist. That's why we have default values. Like if it's saved out as binary, the field has to exist. Whereas if you save it as text, you might add and remove fields, so fields might not exist. So the default value is there to catch that case. And I guess it makes sense to be able to change the default values in that case. Because as soon as you add it, you might put the wrong value in and then you've messed it up. You got to up the version, and that's a bit weird. Yeah, so I think that makes sense. So we should get rid of this then. It's fun that when they start walking, they can learn. They can start moving around faster because then you have to be alert in a whole new way and keeping an eye on them. Yep. See, right now is like the house is kind of baby proof, but it's not like super baby proofed. So we always like just keep an eye on him. Like if we're out in the kitchen and he's in the front room, we like peek around or we listen out for him. And if he's too quiet or something, we'll just like peek around. But yeah, or typically we're just always with him. Other than that. But yeah, as you're saying, when he moves around, he's so much quicker. We've just bought a gate, so we need to fit the baby gate because he can climb the stairs now. He's getting good at it, and it's great because when he climbs to the top, he starts clapping like, "Yay, I did it!" Yeah, good times. Yeah, it's pretty fun. Like, yeah. Like I knew having kids was great and fun, but I didn't realize how much you would like really like enjoy all the silly things your child does. You know what I mean? Because when someone else tells you about it, you're like, oh, boring. You know. But now that I have a kid, that's changed. Um, you know, and I can like, eh, you know, understand that now. Whereas before I couldn't really. Um, but yeah. Um, um, all right. What's the next sort of one to do? Type, kind, structure. Yes, this is if the field does not exist. You're going to say, hey, it's removed. So this was an old piece of code because we used to have structures and tables. I kind of got inspired by, well, I was thinking about having these structures which were sort of fixed size and tables which were unsized, kind of inspired by flat buffers in a way. When I saw it, I was like, oh, that's interesting. That's kind of what I want to do. So I followed with that. But then I realized this kind of was silly. So now we've got text files you can change stuff around in, and binary files they're kind of fixed. Or they're more fixed. They're in a way. Um, so we just mark it as removed in that case. So any other sort of rules? Renames. Sometimes it renames. No, but you can add a remove. Yeah, you can't rename because the type would then be huh. You can rename a field. Oh yeah, but if you rename it, yes, if you were to rename it, it would just work, but it'll class as a remove and then an add. There's no way of really catching that, I think, because yeah, there's no way of really catching that. It's just an add and remove. That's okay. Yeah, that's good. So I guess we just got to do the same thing for a enum, right? Make the same changes for the enum, and then I guess we can run it and get checking to make sure things work as intended. There is the versioning stuff we haven't tested out yet. But yeah, let's take a quick short break, and then we'll sort the enum stuff, and then we'll take it for a test run, make sure it all still works as intended. All right, BRB. Right, welcome back everybody. Right, so for the text, no, for the enums, we need to sort of like text file thing or, yeah, so we'll copy that with the comment in there as well. Right, so if the underlying type changes, that's a problem. Oh, did we not list that? So for text files, yeah, so the underlying type can change. Can it? Can it for text? Or maybe it's just a common thing, right? So for a binary file, if you just change the sign, not really a problem. The actual values, yeah, if you change the actual values, that's a problem. Whereas if you change, so for a text file, if you change the underlying type, yeah, so in a binary file, if you change the underlying type, it's going to in turn change a structure. The fields are going to be, yeah, so you can't change it in a binary file. But for a text file, if you change the underlying type of an enum, so if you make it a U16 from a U32, that's not really going to break anything unless your enum value does not fit within the bit range, which is something I don't know if we've... Yeah, so I think that's only for binary, right? So actually, that's another thing we can probably support. Is for text files, you can change the underlying enum type. Enum underlying type, but you can change it for the text files without updating the version. It seems to make sense. So actually when we go and process that underlying type, it's lying. It's so inconsistent. It's underlying, isn't it? Right. English is my first language. All right. So when we do the actual underlying type, parsing code, do we check to make sure that the values fit within that range? Got to be careful here. Parse number. Verify basic value. Yes, we do it. It's good. Cool. Happy about that. So let's get back into here and go full ham. So underline type, this can change if it is text, but it can't change if it is binary. So we'll keep that one for the binary one. So what's interesting is that, there we go. This one is for the did we remove that thing? Oh, damn it, I'll go into the code again and find it, into the diff. And find whether we had this, because if we added and remove files, we just used too problematic. Huh. Where am I adding fields in here? And actually doing this is bad. Because it's not going to keep... Oh, no, it'll be fine. No, it won't. Problematic. Because it's not going to keep those removed flags. Maybe. Oh no, it's dev mode. It doesn't matter, you can overwrite it. That makes sense. Right, so let's check the diffs quick, because I wonder... I wonder if we removed that. So that's in the merge. Here we go. Yeah, I think we didn't have it in here. Right, let's finish off the enum one and we'll come back. We might have to do something like this. So, okay, so for binary, you would like to go over all of the... You cannot add and remove stuff. And then you want to go over all of them. It might be just like this, to be honest. And then you want to make sure that the values are the same. Hey, Death Waiter, how's it going? Welcome. Yeah, so we're looking for enum. So where it says strut, basically replace that with enum. Where it says field, replace that with value, because enums have values and not fields. And I just realized we simply messed up something. This... We didn't put the format args. So it's source followed by destination, I think. Alright, so I need to do a similar thing up in here. Enums, binary file. If the value counts differ, enum value, enum value. That's a problem. And then we go over all the enum values. So we'll call this an EV, enum value. So this one's saying that there's a type mismatch, basically, but that's obviously only for structures. So instead for here, we want to say if destination EV value, and we'll take it as a UN, but it's just a union, so just compare the bits. If they differ then right, enum identifier value identifier at index this has a with value VV, I think it is. Yeah, VV. VV, then it checks underline type and does signed in or in, yeah. In the database, it is crap. We don't have two formatting things. This sucks. Yeah, this is not going to be good. Because it could be signed or unsigned. Well, I could do v lowercase v. It's a bit dumb, but sometimes you just got to do what you got to do. Does the exact same thing, but instead of looking in one of them, it looks in the other one. And yeah. Right, that solves the problem. If you like to change the type blah, put it into dev mode. That whole thing is reading wrong. Put the enum into dev mode. It's just all trash. Just put the file into dev mode. Tell me how many of these we got. There's another few, I think, somewhere else. We'd like to change the value. So you can rename them. You'd like to change this field value. Yeah. Alright, put it into dev mode. So I think that's it for the binary. The binary, yeah, just doesn't want to use, yeah, has to keep the same number of enums. You can't add and remove, and they have to be the same value. And the underlying type cannot change. That's all of those there. The next one is the text. So the text, you can, probably all of this code here. So we'll go over all of the destination values, the one in the database, find the corresponding enum one. To be honest, I've got a function for that now. It's called like yeah, but I'll do a manual hash actually. We'll leave it as that. So if we find it, we make sure the values match. So in the text file, if we save it out as text, then if we save it out as text, then you can't rename it, but you can change the value. But if you save it out as the value, you can't change the value, but you can rename it, right? So value the ability to rename the enum for binary, but yes, you want to rename an enum value. That requires upgrading for text. Whereas without upgrading, you can add and remove ones. You can change the underlying. Add and remove enum values. We should be able to change an enum value. Remove the enum with the same name. Yes, you cannot basically reuse the same name. And the name will get looked up and turned into a value. So realistically, you can change the values as well. Is that a good idea though? Because if you can change the enum values, you'd have to do the version upgrade afterwards. I think that's okay. Yeah, so in this case, we just need to make sure that the name matches. Right, if the name is there... Wait, how will you do it? Reuse a removed enum value with the same name. How are you going to do that? So here's an enum, right? If it's in a text file, I save it out. And then I remove one of them. Well, I try and... If I try and deserialize it from text, and I get pig, or pig doesn't exist anymore. So what do you get? Do you get 0, like the default one? Or whereas, you know, maybe you can just only add new enums for text files. But then you're going to want to be able to like really remove some as well. So is that just a serialization error? If you were to remove pig, you get pig, whoopsie. We can't parse that, right? Or at the end of the day, the ent type is going to be a field down here, so maybe it just defaults to the default value because you read something invalid, right? That's probably what we can end up doing. Where's that default value stuff that we've got in here? Unspecified default value, enums are zero initialized. The zero initialized doesn't really make sense. We could say it's the first. Yeah, we should say zero initialized. You should really always define a zero for an enum then. So if we have a removed, like this would just be in the text file, right? So if they've got something invalid in there, it will just default to the default value. And maybe we'll print out a warning in the console. Yeah, maybe that's what we'll do. Okay, so we're going to write that in the documentation. Because that just seems a bit bizarre, right? Where am I going to put that? Encoding and decoding are decoded by calling the code generate functions. Yeah, I guess, okay. Well, you want to be, yeah, so we'll just make it default if it's the default value of one is missing. And that will still make sense. So how do we finish this off then? Right, so when it comes to the validation checking text-based ones, you can add and remove them. You can change their values, right? The values don't really matter. So regarding these rules, add and remove enum values, right? You can just add and remove them. You should be able to reuse and remove the enum with the same name. You can do that. The things you can't do with a different name. Why not? Right. Say if you communicate over a network or whatever, you have two slightly different compiled versions of the game, and they have the same text file version basically, but the enum values are different on each compiled versions of the game, but they use the same enum names. You'll send one over the network or whatever. When it deserializes it, the value would just it would just match up to that person's one on their machine, right? Okay, that makes. So it seems like if we share this stuff around, it will still be fine. So really, we should be able to change these rules. Upgrade. Bit too try hard. Back on some Nick Johnson. Right. So back to those rules. So actually, the text files we can remove this line here. Reuse a removed enum value of a different name. That's all right. It's fine. So you can actually change enum values. You can just change them. It's fine. So the problem is the renaming. Yeah, you can't rename it, but you can change the values. Names. But you'd need an upgrade, but we can't catch that in the system because it's impossible to catch that. It would just mean your files won't. If you change it, yeah, you won't be able to upgrade past data basically. Kind of a bit problematic though. Say if you're using the text format and you go, right, I got a dragon here, but I want to call it dragons for some reason. All the past data you've saved out, now will default to the default value because you've renamed it. So the way you could catch that is if you meant you cannot. But it's the same with structures as well, right? For text fields, if you change the name, you no longer can parse the old one. Yeah. But to stop them from changing the names with the system, you'll need to be able to somehow verify it's the exact same field, so you wouldn't be able to reorder them. You wouldn't be able to reorder them, and you wouldn't be able to so if you reorder the structure, you have to limit them to keeping them in an order, and the types. Well, the types already have to stay the same, and then in that way it would be like the binary file. But then you could catch them renaming it, right? But then they can't add stuff in between, and the whole point of text is so they can add and remove stuff. So I think this is just the nature of text. For text, it's like the identifier is the key, and if you change the key, it's a problem. So you have to do an upgrade if you change the key. Right, so it sucks that it's kind of outside the system, that thing, but yeah, that's okay. Right. So in this case then for text, you don't really care about the values. Changing, you don't really have any validation for text, basically. You literally just say, I think we can literally just say, just copy them all over. Slash changed values. Right, just copy them over. I don't think you really have a problem with them. Okay, let's go do it that way. Right, so that leaves me like one more thing to question, and that is for structures and unions. Maybe we should be explicit about that. Yeah, for structures and unions, what happens if we add and remove fields? It's a bit problematic. For text. And the reason is because I don't think we're actually copying them over. And I think we were in the past. I don't know. I don't remember what's going on. But the text, we go over all the destination ones, the ones in the database. We try and find the source one. Right. If we find the source one, it's not removed. If we don't find it, so this means that they could maybe. Yeah, they've got to be added in. But my concern is how we're going to do that. Because we've got to retain the removed thing about it. What they do here is if they're in dev mode, we just copy it over and translate everything. But it's not going to keep the removed fields that way. I wonder how we're going to solve this problem. So if it's a text file and we sort of like remove one. The removed is fine, it's just adding, isn't it? Yeah, it's just the adding. So we used to have a thing where we would track the number of like, we would do a bit set for every field that we have. Let's do the git, it's right here. We used to have a bit set. And we used to say, well, if the bit set has been, here it is, the bit set. If the number of bits differs, then it's an error for a structure. But there's nothing to do with actually keeping the new values in there. Sorry, keeping the new fields. So we've got to find a way to insert new fields into. And the problem is we can't just add it to the end of the array because all fields are allocated in one big array. So you kind of have to like copy them out to another one. So I guess we could, yeah, you could just push them on if you find a new one, I think. Yeah, maybe that makes sense. So what you want to say is, all right, I think this is the way we're going to do it. So now we're going to go over all the source fields and then go over all the destination fields. Right. And then find the field we're looking for. If we don't find the field we're looking for, then we're going to add field in. Now we've got to make sure that, we've got to be super careful, but we have to make sure so how do we know if we've found a new field equal false? If we've not found a new field, we need to copy everything over to the new place. So you'll say, if not found new field, we'll bump allocate. So we'll then say, right, we'll say structure field, new fields, call them DST fields, core stack push many onto destination type table, structure fields, and we'll just allocate all the ones that are available in source type. Right. Well, it's the max, isn't it? Yeah, we've got to be careful. And also, like, the count might have changed as well, isn't it? The count could have changed. So no, wait, removed. You never remove fields, you always add new ones. So it's always like, what's the maximum allocate? You don't know how many new fields there are. You could have had, so I guess like the capacity is basically adding the two fields to get the two type fields together, because you could have technically just done a whole new set of fields and the other ones just don't exist anymore. That's possible. So we allocate that many, and then we simply do a copy, core copy element many. We're copying into destination fields from the source field. Wait. From the old source fields, destination type, structure fields. We're going to have to copy the identifier hashes as well. Yeah, we'll need to allocate those too. So now we've copied it to a bigger buffer basically. It's locked in a realloc essentially. That's all we're kind of doing here. Fields equals DST fields. Now we've got to do the name hashes as well, because they're kind of used. So they use 64s. Let's just get that right. Field hashes. Alright, let's get all those in there. They're called ident hashes, aren't they? Yeah. Right, ident hashes, destination field. Right, that looks alright. So, the next thing to do then is, that is the realloc. Now all we need to do is bump the rest of them on. So whenever you want, so hey, I've come across a new one, I literally just bump it on, DST field, SF I guess we call it. Already got it declared up above. We bump one on. Then we do the copy from the source field. And then we do the translate. Translating the type over. So that. Translate the data type of the field over to the Encoder database stuff. And then we need to make sure we up the count as well. So you need to then say dst type structure fields count plus equals 1, and that will up it by 1. Yeah, that's pretty legit. So that's going to go ahead and fix that problem. So we'll go over all of the add any new fields to the database struct type. So if they don't exist, allocate the worst. Seems all right. No. So there's two problems, right? First problem is that actually the identifier, the hash needs to get put on here. Where do we get the hash from again? Source type structure, and it's whatever the source field index is. Oh, I've already got it. Damn it. Already, that is simply just source ident hash. Nice, so we've got to push that on as well. Now we're doing these pushes, right, but we've already pushed too many on. Actually, the capacity that we need to do is bump allocate. Yeah, we don't have to over allocate, which is good. We just allocate as many as we need for the destination that it already has, and then because it's at the end of the array, we can bump allocate the rest. That makes a ton of sense. Okay, that's good. I'm happy with that. So I think, right, so that's all the validation stuff done for versioning. We've still got to do some validation stuff for so when you change like types, then it will error. We've still got to go ahead and do proper checking for some things though. Like some features might not be enabled or something like that. Like you can't use packed in GPU, like stuff like that. Yeah, my one concern with this design as it is, so I guess we can run it, right? All right, let's get it ran, okay. So my main concern with the design at the moment is that the text file you can change stuff, change identifiers, and that will technically break. So maybe what we should do to get around that problem, like, because here's the thing, right? I want to have the ability to sort of edit the file, edit this encode file, without having to think about anything. That's the main thing. Think about absolutely nothing. And the system will be like, hey, you've done a thing which is a problem, right? So being able to remove fields, if they're used in text files, is a problem. Because yeah, just being able to remove, like, so maybe you can definitely move them around. You can reorder. That's not an issue. But for a text file, like, if I rename a field, that's the problem, right? If I rename it, I've now lost the data that I would be reading, because it wouldn't actually read the field that it used to be, because the key would be different. So I think what we actually need to do is the removed side of things needs to actually be changed. And I think that would give me peace of mind about just editing the thing without thinking about it. So I think what we can do is we can always add new things. We can add new fields, we can add new values, but we cannot remove. Rename / remove, you cannot do that. So reuse removed thing with same type. No, you can't do that. You can change the values. Unpacked. Maybe you can't rename. Right, I think that makes a ton more sense. So how will we achieve that? So we've already got that removed thing. So now the code could be made maybe simpler. So this is removed thing can now go. We don't need removed because things will just persist, right? You just always add new things until you need to do a new version, and then you can just clean it up and delete stuff if you wanted. So removed is being removed. So realistically for enums, you cannot remove stuff. So we need to check for that now. It's not a big deal. Shouldn't be too bad to do. So we go over all the structure fields. This remove is a problem. Yeah, so that's another thing. We might not be copying over all the stuff that we need. Right, let's get this in quick. Right, so in this case, field has been removed. If you'd like to change this type, put the file into dev mode. Cool. Right, it's a good check. And then inside the... So we need to do the same sort of thing. We'll see this adding thing, right? You know, we could just do a thing, you know, maybe we don't need to do this anymore because this is actually a bit expensive doing this. It's quite n squared kind of. So it might be better just to be like, well, use the one from the source type when it verifies to being true, and then run over all the things and translate them. Yeah, okay, that's what we're gonna do. We would just do something like this. So I think the way we're gonna do it is, where's those things? Here they are. Okay, so after we verify that everything is okay, we simply just copy over the arrays, or the pointers for the arrays, inside the types, and then we simply run over all of the fields and perform a translate to the new database, or the types. Yeah, for the types. So the enc file has, let's just say added. May have added fills. May have added fields. Just use the source struts arrays as inserting them will be too problematic. Well, it won't be problematic, we just wrote the code for it, but you know, it's more complicated, right? Goodbye. We shouldn't need that, right? Yeah, because we removed the remove thing, so it's just a case of copying it all over after we verifying it. So we verify. So because we're verifying it here, we don't actually need to copy anything over. This is pure verification, and that means that everything's okay. That's cool. Right, so one more thing is that we need the verification now for the enums. So enums need a bit of verification. Stuff cannot be removed. So we need to do the old find and replace. Right, so look out for strut as well and replace it with enum. Nearly there. Alright, so this one is enum value like so. And then rather than SF, meaning structure field, is EV for enum value. Right. So we go over all the destination values, then we go over all the source values, see if we can find the matching one. If we cannot find the matching one, it's a problemo. And we're trying to say enum this value vi, so value identifier has been removed. Nice, pretty good. So that does all the verification, then we'll just copy everything over just because like, it's okay. Right, that makes a ton of sense now. That's much better. Now the system is basically, you know, I can be very unaware about how the system works, change stuff, and it's not going to bite me in the butt. So what is left to do? I want to make sure that the verification rules make sense for the right, what a union, and they've got these sort of tag things, right? So if I change the key, that's something I've not thought about. So we've got this sort of like tag thing, right? Maybe this tag cannot change and the keys cannot change. They have to match, say. So if you change the, so as a text file, see, as a binary file, right, these key things don't matter. They're only ready for text, isn't it? For decoding and encoding. So if you were to sort of like, you were to change these, and then the database takes those ones on, is that a problem? So if you have an old text file with the same version, but you've just changed the enum, for whatever reason, you've changed the dragon to use frog instead. Right, the frog one instead for some reason. Ones that would have had dragon would then give you back nothing. Yeah, it is problematic, right? Because you end up reading some data would have been saved out without anything in there, because if stuff had been saved out with frog before, it wouldn't have had any data in there at that point, but now it would have data. But then again, if it doesn't exist, you would use the default value, isn't it, or something like this? So if it's saved out as frog, when it looks like this, it would have nothing in the data field. There'd just be nothing in there. So then you change it to read something, still has nothing in there. The dragon would just be default initialized, which would be to 0. Then you are just discarding a whole bunch of data, really. Yeah, I think we should, if the key changes, yeah, the key cannot change as well for text without upgrading the version, I think. And same for the tag, right? If you change the, yeah, so we'll write that down in the thing, and we'll do the error checking for that quick. So upgrading. Oh. Okay, so for text, so you must, if you were to sort of change the tag fields, change the sort of tag or key names. That's a problem. So we can fix that in here. We just check to make sure that if if you have a tag so cast as a boolean. If you have a tag and they're not equal, it's an error. Yeah, so if you have a tag and don't have a tag on any of them, then it's an error. Where you've removed the tag, or I guess in this case you've removed the tag, isn't it? Now you always must have a tag. The key, you always must have a key, is that right? Hey, Devince Dev. Yeah, so the encoder system is for a few things actually. The main thing is for files, where I want to save stuff out to files. I want to have a text file and a binary file. I also want to have versioning. I also want to have upgradability. So the encoder is a whole the encoder system is a whole system that does all those things, but it also is going to support GPU as well. So be able to put on certain restrictions, which will say like you're restricted to using 4-byte types, and it won't use pointers in any of the code generated code. So essentially, it's like a C-like file. It's very much C, but with a few extra things to make it work. And we do bit fields differently, where we have these sort of ranged things, so it can do all the packing code for us and unpacking. It generates all the code for that, which is nice. But yeah, so it's mainly just like an overarching system where it has a set of rules. You don't have to know the rules off by heart, because the system will catch problems. Like if you change things which you weren't allowed to change, it will let you know and tell you how to upgrade versions to sort of make those breaking changes. But yeah, that's mainly if you have versioning and upgrades. But if you don't have versioning and upgrades and you purely just use it in GPU land, it can just be used as a way to generate packing and unpacking code. So yeah, that's really what the system is. It's quite complex, I guess, but it does a range of things, and it's used to mainly also want to be able to preserve files between versions as well, because I'm making like an editor with assets. So I want to make sure those assets can be preserved. So yes, kind of solving all those problems with one system basically. So that's what the encoder is for. Right, so if you don't have a tag, there's a problem. What about a key? The keys required? What keys were required? Missing key directive. Oh, what am I reading? So if we're encoding for text and the type is a union, I think we need 2 of these. Like for a union, every one of your fields needs a key. Right, so this was clearly a bit wrong. So if your parent type, I don't open up for key anywhere else. Okay. So if it's in text mode and the type's kind, so I guess that's strut kind, is a union, and the key is null, then missing key directive on union field. To specify the tag key, you need this because the text format is being used. Yep. Then this one's saying if the structure field is a type kind of union. Yes. And there is no tag. That's a problem. So missing the tag directive for a field which is a union. So you put a union within a union. Yeah, you can't do that, can you? That's going to get problematic. It's a directive for a field with a union type. Union type field tag field. Great. How's the game journey so far? Yeah, it's going alright. It's going pretty good. I got a yeah, there are only 21 people here, I think. This still runs. Yeah, so we've got like sort of ray traced ellipsoids. It's a bit glitchy right now, but we've got like an entity system here as well. We're just testing it out. It's got a bunch of different regions, and these entities all live local within a region, so they're all next to each other in memory when they're in the one region, and they shuffle around when they move between regions. Yeah, we're currently working on building some. Well, we're going to be building some, like a way to basically make levels and entities within the game, so we can actually build content. Because that's one of the things we're kind of missing to carry on more with the renderer. Is we really need a bit of content, so we're going to be able to make some quick content in the editors, and then do more rendering. Like we've got PBR basically, but it would be good if we could make that better and make lighting better basically, because we don't really have shadows, we just have two lights that are kind of fixed. Yeah, so it'd be good to just make the renderer more complete, and that'll be after we've done all this editor stuff basically. Yeah, got entity update. So all the rendering, we've got like some render data that gets produced by the game logic, and then that gets passed to the renderer. So that's all done using the entity system, which is pretty sweet. So I'll loop over all the entities with a renderer, with the ones that can be rendered, and then it will make the render data and pass it to the renderer. Is that fun? Good luck. They're going out right now. Thank you so much. Appreciate it. Right, so the tag and the key has to exist. If they have to exist, yeah. So what we're saying is like, yeah. So we'll just say if one of them is there. Oh. If you have a tag, verify that the tag matches. And core string equal now tag is actually, thinking about it, pointer. There we go. Need to get the ident. Alright, so if they're not equal, right, tag has changed, tag cannot change. Field blot, tag has changed. Hashtag mismatch. In the database, it is, right, we'll say like, why is there a semicolon there? Right, so here we can just do these silly things. And then we'll copy paste it for the keys. The way I structure my engine is the renderer takes a renderer callback, which gets invoked for shadow passes, and then the image that keeps the renderer and scene updates separate. Right. Yeah, I'm not sure what you mean by a callback and how it keeps it separate, because where does it get the data? Yeah, so for mine, you just create an array of objects. So there's just an array of, yes, you have a payload, and the payload contains an array of model instances. And every single time we come across a model instance, we push a model instance on. And if we manage to push it on without overflowing the buffer, we fill in the data. So then that, when you say render frame, which can happen on another thread, so this payload can get passed to another thread when we do threading. We just pass the payload and that has the arrays of data in there. So yeah, it keeps the scene and renderer independent too. Okay. So we've got the same check, but instead of tag, it's key. Cool. Right, I'm glad we sorted that out. That's really nice. Oh, so we're pretty close now. The verification is looking good. Right, we've still got to test it, but it's looking good for enums and structures. The logic is there now, and we've thought it through and written it out at least. We've still got to sort out a bunch of little things to do with the rules. So we'll probably do that next stream. We'll probably read over this and just double check that all the things are being handled correctly. Then after we've done this, after this has been done, we can then move on to code generation, where we can generate all the structures and all the text decoding and encoding code. And then start testing it all out, really. There'll be some more things we need to code up other than that, but yeah, at least this system is coming to a close. It's great. Yeah. So I guess we'll take it all for a test drive next stream. So that would be on Tuesday at yeah, it's 4 hours ago, basically, on Tuesday. And then Thursday as well, same time. And then also next Sunday, kind of at the same sort of time. Let's just find someone to rate quick. But yeah, in the meantime, there's a Discord channel if you guys want to hang out. Just like that. Maybe we'll raid the Zig guy. Yeah, take care, Campaign. Good to see you. I'm so tired right now. I'm gonna go eat some food. Oh, it's gonna be good. Right, have a good start to your work week, guys. I'll see you all in the next one. Appreciate it. Right, catch you later. Bye-bye.